to our presentation. We are Group M and today we will present our final solution. This is the order of our presentation. This is our business model map that we use with all the steps that we follow to come out with your final design. And this is the last stages that we are at the moment. This is the platform level where you can see there are different sets of stairs, different locations. And this is an intermediate level that serves as a landing. That connects the station with the visitor center, where we have some shops and a supermarket here, and also we also have the exits of the station. So these are the plans of the visitor center. This is the level that is connected with the station, and as you can see here, we have toilets, we have the station info desk, a changing room, the storage room, and a machinery room, and this is the level above it where we have the offices, a cafe, and an open space. This is the ground level of the visitor center, where you can see here the information desk, the visitor area, a small cafe, and a small gift shop.
This is the video walkthrough we did in Revit. As you can see, this is the visitor center and the perspective of the Pinacoteca in the background. As you go downstairs to the outdoor space, the sitting area, you can see the benches here, and this is a little bug produced by Revit. You enter the visitor center, you can see a cafe, and those are their offices that are closed. You go upstairs to the ground level. You can see the information desk, and this is the exhibition area. And you go out, you could see the entrance to the U Bahn, and now you have the perspective on the visitor center from the Arzerstraße. Structure analysis. These are the loads we calculated for our structure: dead loads, live loads, wind load, and the snow load for the visitor center. Also, we decided on soils we will be using in our project. This way we calculated the foundation modulus of the visitor center foundation slab and for the U Bahn station foundation. Also, we have calculated the pressure from the soils on our structure. We decided to divide the structure analysis into two parts. U Bahn station structure analysis was done by Mustafa, and I did the structure analysis of visitor center. Our idea was to use the rooftop, that is the hyperbolic paraboloid shell. We have been inspired by Schlechem-Bergmann Partners project and use those materials for the rooftop. That is the PTFE coated glass fiber membrane that is supported by steel cables that are held by the reinforced concrete beams. Although the idea was nice, but we have encountered some problems with exporting the surface into Sofistik and calculating it because it's not supported as analytical surface. So we had to additionally model this surface in the Sofiplas, export the model from the Sofistik, model the surface, model loads on this surface, and export it back to Sofistik. To our own surprise, we did it successfully, and you can see the results in Sofistik, the structure under the wind load and snow load. Also the results in Sofistik graphic, the normal forces in beam elements and in cable elements. Thank you.
Hello, I'm Mustafa. I'll start the structure analysis of the station PITE structure system. Our structure system was like system P. We used single row of column at the middle, but we changed it to be like system A to carry the slabs over the internal walls without using any internal columns. I'll show the analysis result in a form of a comparison between the two systems. For bending moment for the beam, we could see the increased value in system A to system P, and for bending stress we could see the effect of removing columns on system A. And for bending stress on the second floor slab, we could see the increased value of positive moment at system A, which affects the lower reinforcement at X direction, and I noticed that system P save about 35% of slab reinforcement. The summary can be presented in some points. System P saves about 35% of slab reinforcement, but additional cost goes through columns, and system A gives more space in the platform and waiting area, and it's about the same cost with system P. That's why we chose system A. At the left you could see the bending moment at the top floor under traffic load and backfilling. At the right, it's deformation under the same load case. For common error I faced during analysis, punching failure error at some points at the exits, which is solved by increased dimension of the column in some cases. Another case I increase the thickness of foundation. Another error is shear failure error, which is solved by increased dimension of the beams. Moving to the construction site planning, the process could be presented in some stages, which starts by excavation to the top floor level, installation of external walls, post-tension slab as a top floor slab, backfilling and road restoration, and strut installation while underground excavation, foundation construction, internal walls construction, platform and middle floor construction, completing the construction work. And for the traffic conditions, the left map shows the traffic before construction and the right one shows the alternative traffic solution during the first 3 stages of construction. Also, I used Primavera to produce Gantt-Chart which shows the construction activities of both UBahn station and visitor center. Planned to start at the beginning of October 2020 to be finished at 22 of April 2021. It's about 29 weeks. In addition, I used the previous timeline to produce 4D simulation through Navisworks. The upper window shows the progressive work overall, and the lower one shows the progressive work through the station.
For the model checking and class detection, we use Solibri, as you can see here, where we detected some errors in our model. These errors were communicated by producing a presentation using the VCF format, which were imported to Revit, applying the VCF manager. Then we corrected the issues and clashes as shown here, and we could proceed with a quantity takeoff. As you can see here, we use iTWO to obtain a quantity takeoff. We obtain the volumes, areas, perimeters of different components. And then the prices were investigated and applied to obtain our final price, which is around 9.2 million. With this, we conclude our presentation. Thank you so much for listening, and if there is any questions, we will be happy to answer them.